All warm up. Yep. Fine. So, guys, anyone would like to add something? Anyone would like to say something? How many of you are moving home for the festivities? Since very few of you have joined today. Fine, if no one has anything to add, let us. Huh. In our last session, we were discussing about broadband and baseband signal. Then we came up uh, with a concern on Wi-Fi and broadband. So I believe that was clear to whoever came up with that question. So in case we still need to go ahead and discuss the same thing, just let me know. Or if that is not the case, we might move ahead. Now everyone is dead silent. Guys, everything I hope is fine. So in case no one has anything to say, let us come to a topic that is not there, like that you might not find in our syllabus, but we need to understand this. That is the mode of yeah, communication. One is simplex, one is half duplex, and the other is full duplex. Any idea? Has anyone heard about it? Anything anyone would like to add or subtract? Because that would lead us to understanding the concept of the transmission. Synchronous, asynchronous, everything is based upon this only. So just anyone having any idea, anything. Is anyone, please, whatever your ideas be, just let me know. Yeah, someone seems to have said something. Anaga, the question is, we can have three modes of communication. One is simplex, the other is half duplex, and the other is full duplex. Now, I don't expect that you would be knowing everything, but whatever ideas you have or whatever you can figure out, I don't want you to Google it right now. Just think what you feel it can be. These can be said to be the mode of transmission. The first can be simplex, the other can be half duplex, and the next we can have full duplex. Communication way, fine. So again, that I have you guys are available. So let me tell you. Mm, maybe okay, no one has said anything. Fine. So simplex can be simplex is unidirectional, where you can transmit data or signals in one single way. The easiest example can be your keyboards or mouse. I am not talking about the mouse that we are using nowadays. Uh, we had those peripheral mouse in the previous days and the keyboards where we were not using USBs, but those ports. So that was unidirectional, where only a part of the data could be sent from my mouse or my keyboard to the CPU. There could not be no signal could be sent from my CPU to my keyboard or the mouse. Fine. And the problem was like I had a channel. Even one bit is being sent, it is using the complete channel. Means whatever you were sending, it would use the complete channel. The whole channel capacity is used. Whole channel capacity is used. And because the whole channel capacity is being used, this might get stuck at times. Now, what happens is you have 100% capacity, and if you are using 80% of it, you still have 20% of 20% remaining. That would help the communication not get stuck. But again, you can compare it with your RAMs. Now, in case you are using 100% of your RAM, the process might get stuck. So the same thing here. I hope simplex was like a little clear to everyone. Now let me show you a block. This is one device. This is my other device. And what I am doing is I am sending data in one particular direction that is unidirectional. In no case, this channel can be used for a backward communication. Means direction one is there, but it can no way, means like even I stop this communication, it cannot send it back. Even at in cases I stop this, it won't in any case transmit on the same channel back. I hope that was clear, or any questions. Might be my words were not very clear. So in that case, please let me know. So I believe that was clear to everyone. Uh, this is not possible in any case for a simplex. It can be used for a single directional transmission, unidirectional transmission. The next is our half duplex. Let us get a block. Now what happens is this computer is sending, so it sends over the channel, right? So this is half duplex. Now till this computer one or this device one is sending to device two, this channel is completely blocked. You cannot send data at the same time. But once this communication stops, you can send data back on the same channel, but it cannot be at the same time. Now, once yeah, 1 to 2 is stopped, you can use this channel to send data back on the same channel, but not at the same time. That is my half duplex. Half duplex. I hope that was clear to most of you, or I believe to everyone. An easy example for this half duplex can be our walkie-talkies. Now, I hope everyone has seen the use of walkie-talkies in movies. Now, what happens is yeah, one of you is sending some data, yes, some information, or he is speaking. Now, what happens is he stops the channel, and the other person is sending his voice over the same channel. Once one of walkie-talkie, everyone I believe has mm, walkie. Mm, mostly, yeah, military uses it. Just I don't know if voice is fine. So you have that many people there? 40. And thank you, Naga. Now, just let us see. But I hope you guys have seen it sometimes in your in the movies. Yeah, the communication using. So that is yeah, that is an example of half duplex. And closing on, we can have finally our full duplex. Most of our communication is like that. Today, most of our communication is like that. PC1 is sending on the channel, and at the same time, PC2 is also sending. At the same time, both can send and receive data. So, in case we can talk about today's communication, any kind of communication, right, that began at the telephone networks. Now we have those telephones. Both of you can be sending data, sending your voice. Now, both of the people are speaking at the same time, though you cannot understand, but still you can send and receive data at the same time. This is true for voice channels. This is true for data channel. This is true for almost everything. So I believe that was clear to everyone, or anyone has any question.
Sir, can you explain again duplex? What is duplex?
Duplex. Duplex. Sure, I will. So let us get back to simplex. Now, simplex, we had those. In case we are not using keyboards and mouses, using our modern day keyboards and mouses, which are receiving signals also. So, in case we are talking about those previous keyboards and mouses, they could only send data. The channel cannot be used for reception in any case, right? You can only send data and nothing would come back. So that was my simplex. Now the next is my half duplex. Now in half duplex, what happens is you send data and then you stop. The same channel can be used for both transmission and reception, but you cannot use it at the same time. In case I want to send you some voice or data, what I do is I send the complete data, the complete packets, I send it to you. You receive it. Now, once you receive it, I stop my communication. Now, once I stop my communication, you can send your voice or data on the same channel. So that is my half duplex. This is my channel. This is my cable, whatever it might be. It can be used for bidirectional, but it can be used for bidirectional, but only time dependent. You can send data at a time or receive data at a time. So that is my half duplex. Now, in case I talk about full duplex, example for half duplex can be the best example can be walkie-talkie. I hope you guys have seen in movies. Now, what happens is two people or even police using it. Now, you might have seen in several movies. Now, what happens is someone is saying something and he says over and out and he stops his communication and he brings his walkie talkie from his mouth and keeps it at his ears. And now, the other person who was hearing at the time, at time slot one, he brings the walkie talkie right from his ears to his mouth and then he speaks. And once he has spoken, he will say over and out and he will stop the communication and the other person will follow suit and he will say, uh, mm, uh, walkie talkie. Let us see if this we can understand. I hope you guys were able to get it. Now, I don't know if voice was that clear. Uh, but what happens is when now now what happens is right now this person speaks and the other one is hearing. Now, if he even wants to speak at the same time, this communication will not help. Fine. So that is what we have for uh, walkie-talkie, and I would share this it in the group so that you guys can hear. Sorry, not that. Let me copy this and let me share it in our groups so that you guys can you can watch it at a later stage and understand this better. So that is a walkie-talkie, and that can be the best example for a half duplex communication. Now, was that clear, Anaga? Half duplex, or whoever asked this?
Yes, sir, clear.
Now, for full duplex, what happens is we have our telephone sets, we are talking, we have our mobile phones, or we have all those channels. Now, we are sending and receiving data at the same time. You can, though both people person speaking at the same time might not be clear, since I won't be able to understand what you said when if I am talking also. But that is your problem, not the problem of the communication channel. It can transmit and receive data at the same time. So these are the three modes of transmission. The first was my simplex, that is unidirectional, and it uses the whole channel capacity. Then we have the half duplex. For my half duplex, it can transmit and bidirectional, but time dependent, or but not at the same time. That is condition number one for my half duplex. So what it is like, one device transmits and other receives in one time domain or at one time. So what happens is when it stops, the other will start. The best example can be, uh, and one more thing, the whole channel capacity is utilized. Whether I send it or the other person sends, the whole channel capacity is utilized. It might ask me to use Z. And finally, example can be my walkie-talkie. Now coming back to my full duplex communication, all our latest equipments are using full duplex transmission. Both devices or both channels can send or receive data. Both devices or stations, both devices transmit and receive at the same time. That is number one. Uh, Now, both the transmission would share the capacity, the channel capacity. Would share the channel. And in case we talk about mm, the examples, so all modern communication would be my full duplex. So since most of you said this was clear, so this brings us to our topic, that is synchronous and asynchronous transmission. Synchronous and asynchronous transmission. So now anyone can think of anything, okay, what synchronous and asynchronous might mean. In what is this that thank for Ganga? I don't understand.
So that clearing out my doubt and explaining again.
That is my duty. But I would like to thank you guys for coming up with your questions. So that is something to be more thankful for than thanking me for clearing my your doubts. So in case you have any doubt, please ask again and again. Even if I flumber, that is fine. But come up with your questions. I would love to. And don't hesitate to ask the same question again and again. That will mean that you are trying. So please, fine. So thank you.
Okay, sir.
Now synchronous and as asynchronous. Now anyone having any idea what do you think? I don't would suggest you to Google it right now. Once we are done, then you, in case you want to Google it out, then Google it out. So first try to have a basic idea, then go for Google. Since again we have so much of data and information on Google that it might confuse you at times. So first have a little idea, then Google. Fine. So any idea what you think of synchronous and asynchronous? Time basics. Okay, good. Again, someone has saved something. Don't know. Fine, not a problem. So, again, Ganga or someone said, yeah, no, yeah, Ganga says time basics. I'm not sure what she meant by it, but she is almost to the point. So, synchronous means there is something related to time. Something is there that is related to time. That is my synchronous. Asynchronous is something which means it is not somehow related to time. Means like there is some time gap or time difference. That things are not synchronous. Now, another example can be, now I am connecting with you. Right, I am connecting with you and we are on the same page. Now someone comes up, कि sir क्या पढ़ा रहे हो? What are you teaching? So that is he is asynchronous. He is not in the same. But you feel like yes, we are connected and we are on the same page. ठीक है? So that is synchronized. Now you might be using syncing your data on your Google Drive. Now whatever new things come to your new files come to your phones, you sync it with the Google Drive. Now your phone or your computer has the same data as your Google Drive. So both are synced. Now your Google Drive is not synced means it doesn't have the latest data that is there on your computer. So I believe that gives you a hint what synchronous and asynchronous mean. Fine. So in case we talk about synchronous transmission, so what happens is synchronous transmission. So in synchronous transmission, let me create a block, a small block diagram. So we have parity bits. So these are partitions, nothing more than that. This is my sender and this is my receiver. Now what happens is the first few bits that is sent from the sender to the receiver is the sync bit, SYN or synchronizing bits. The first few bits are synchronizing bits or syn bits. And after that, you are sending the data. So you have the data till here. Now what happens is the sender sends in and this receiver receives this sync bits, the synchronizing bits or the synchronizing characters. Now these sync bits will contain the information about the sender, the amount of data that would be sent, and other information. Now, based upon the data that is there in this sync bits, now this will not contain the real data that I am going to send. This will only contain the sender address, the receiver's address, the amount of data, the payload, and all those things. And based upon this, the receiver will close all other channels. Now, this receiver might have several open ports. Now, in case it receives some sync bits, now after receiving the sync bits, it will decode. Okay, this is coming from, like suppose Anaga is sending it to Nashik. So Anaga, I will use the channel right now only for the communication from Anaga. She is sending me 20 megabytes MB of data. So for 20 megabytes, I would be needing, depending upon the my channel capacity, I might need 12 seconds. Now 12 seconds, I will keep my communication channel with Anaga open and I will close only after that. So all this information is there in the sync bits. Now, once it receives the sync bits, it will synchronize its communication channel based upon those sync bits. Now, once the sync bits have been processed, the communication channel has been cleared up, the data will start flowing and the data will stop only once the complete data has been sent. So I believe you have a rough idea how synchronous transmission goes on. Now, a few things about synchronous communication, just you can type in case you didn't understand, just let me know. Now, a few things about synchronous transmission. So, in case I'm talking about synchronous transmission, the complete data is sent in one go. That is why it is relatively fast as compared to my synchronous transmission. The other is you can use this channel for large transmission, means like heavy payloads. Heavy payloads can help. So, anyone having any question? Fine. And the last thing that I would like to say, which I stopped, that was because we are creating a dedicated channel, it might uh, be a little expensive or as compared to my asynchronous channel. So let us not write expensive right here. Uh, I will better use uh, cheaper when we would be talking about synchronous transmission. So that, yeah, asynchronous transmission. So that is my synchronous transmission. Now, in case I talk about async, now in asynchronous transmission, we are converting a large payload into different data packets. Now, each data packet is having a start and a stop bit. Now, let me show you how it is. I will not make it so big this time. Now, suppose this is my sender and this is my receiver, and this is my direction of communication and the communication channel. So what happens is I have a start. Sorry, let me have this start bit first. Right. After this start bit, I would be having my data packets. That would be bits. One. So we would be having bits, and that would be followed by my stop bit. So once I get a start bit, the receiver understands that someone is trying to send some data. Now here you don't have the sync bits, but each data packet would have, now this is my data packet. Now this data packet will complete have certain bits that would contain the sender address, the receiver address, and everything needed for my communication. Yeah, it might be having the encryption bits also. So whatever is needed would be there in these packets. Hopefully, we would be learning about these packets very soon. Now, once the receiver is receiving the start bit, it will open this channel and this packet would be received. These packets would be very small. They would require a transmission within a millisecond or even less than that. Now, every communication channel that would be open for a very small time. So very small time they would start, and once they are started, the complete packet would be received. That would be within a millisecond, and once it is received, the stop bit will confirm that the complete packet has been uh, received, and now other packets that would be coming, they would be coming at a different time. That might be a second later or whatever the time might be. So this is a synchronous transmission where you are converting your data into smaller packets. Is each packet is having a start bit, a stop bit, and other bits that are needed for my communication. The problem arises, uh, there can be difference between data packets. Now data can be having gaps. So that is a problem, but it can be more efficient since several ports or several channels can work at the same time. You don't have a dedicated channel. That is why it can be that is why it can be a little cheaper as compared to my synchronous transmission. Now, anyone who did not understand, please let me know. Fine. So, getting back, this synchronous transmission mm, uh, can be used for heavy payloads. That is the biggest difference. And that is the biggest thing about synchronous transmission and asynchronous transmission. You are sending small packets, and each packet is having a start and a stop bit. That is what needs to be understood, and that needs to be taken care of. So then we can have a little mm, differences between those. Uh, flow control method. Yep, in synchronous and like you have to wait till the complete data is sent. But in asynchronous method, you don't need to wait for the you don't need to wait for the complete data channel, and that would uh, make it a better communication. Synchronous transmission sends data in form of blocks of frames, while we are using bytes or packets. Synchronous is faster, asynchronous might be slower, but it can be more effective. And asynchronous transmission is economical. So these are the few differences between synchronous and asynchronous transmission. I believe that was clear to almost everyone. So let me get back. We are having almost 32 people, and Someone told me that 23 people are mm, from Trivandrum. So I believe we are having only 9 people from Chennai. Is there anyone? Anyone from Chennai? I hope no one is there from Chennai today. I hope from Calicut, this means only 9 people are there from Calicut. Rest everyone is from Trivandrum. Is that so? Trivandrum, please confirm.
Yes, sir.
Fine. So, like, no one is from Chennai and Trivandrum, 9 people and 23 from, yeah, 9 from Calicut and the rest from Trivandrum. Fine. So, guys, now in case anyone wants to Google out synchronous and asynchronous, and in case anyone wants to have even needs to know more about these, let me know. We can discuss more about it. Now, let me tell you one more thing. This start bit is normally a 0 and the stop bit is 1. That is our standard for asynchronous transmission. Now, what happens is my communication channel, it gets interrupted. 0 means no current. It gets interrupted for a clock cycle. This means that it would be followed by data. I believe you might come there would be a question. Okay, why are not we keeping this communication channel at a 0 and then make this start bit a 1? So we would be coming up with that with the answer to that. Uh, Someone has said something. Okay, sorry. So now it is carrying yeah, it is flagged up means like it is the communication channel whenever it gets a 0 for a clock cycle. Uh, it understands that there are a few bits that are coming after this 0. So the communication channel is active for the few milliseconds that it is needed, and that is followed by a stop bit that is a 1. Now, once it gets a 1, it will remain flagged as 1. Means like my communication channel, after receiving the complete data, it gets to a voltage level of 1. Now, that voltage level 1, that is not followed by any 0. That would mean means like once I have the parity bits and everything, this stop bit One could mark the flag as one, means like it will remain at a high state, at a positive one level or a positive level, till it is again marked by a zero level of start bit declared by the processor. So I hope that was clear for most of you.
Yes, sir.
Fine. So, like our next topic would be the protocols. So now let us not discuss right now about protocols. Let us first try to understand the packets. Once we have understood the packets, we might start with the uh, protocols. So a packet of data. Okay, fine. So now, can anyone does anyone have any idea about a data packet? Anyone? Anyone having any idea? So to understand this, let us understand we can have multiple communication channels. Now suppose this I am requesting data from several sources. Several sources. Now uh, an easy example can be, suppose I am downloading data from several different channels, from several places. Now, what happens is we can have the synchronous and asynchronous transmission. The synchronous transmission would be like, okay, so this is a play, yeah, like I am trying to receive data from four different places. Now, from four different places, what happens is, in case of a synchronous communication, one channel will start sending and I will not accept anything from any other channel. Fine. Suppose, for example, I am downloading something from my Google Drive, suppose, from YouTube, from Netflix, from Amazon Prime. So this would be just for understanding purpose. So four channels. Now what happens is, in case I am using synchronous transmission, I requested everyone to send data. Now Google Drive will start sending and all other channels would be stopped. No one else would be sending anything till the complete 1.5 GB is received from Google Drive. Only then can YouTube start or Netflix start or Amazon Prime start. This will mean a lot of data in other channels would be wasted. Right. So what we do is we prefer asynchronous transmission. Now let everyone send its data. Every data that I am receiving might be 1.2 GB. It would be downgraded to small packets. Those packets can be 5 KB, 10 KB, 30 KB, 50 KB, depending upon the sender and the receiver and the kind of channel I have. So now once I understand this, what I do is I make packets and I at the same time Amazon is also sending packets to me, Google Drive is also sending packets to me, YouTube is also sending packets to me, and Netflix is also sending packets to me. Now no packet is destroyed. I do not have to wait for one of the senders to stop sending that data and then receive the other one. I can receive data from all the places at the same time. This makes asynchronous transmission more usable, and this is why, though synchronous transmission might be faster, still I am preferring asynchronous transmission since the, nothing is getting wasted. I am receiving from everyone. Each packet has a lot of information about the sender, the receiver, and everything. So what I can do is once I receive everything, I will arrange each like every packet in the order and with the name from which it has been sent. So I believe that makes you aware. Now let us again understand that uh, these will use protocols that is good. Mm, Now we have talked about 32-bit and 42-bit, right? So we talked. Uh, so when we are talking about 32-bit processing or 64-bit processing, same thing comes in my data communication. We can have 32-bit packets or 64-bit packets, depending upon the communication channel we can have. And a 64-bit processor might accept not only 64-bit processing, but also addressing, but also 32-bit and 64-bit packets. So they might seem to be unrelated, but in the end, somehow 32-bit processing and 32-bit packets, they can be taken to be on the same platform. Now, let us understand the packets. So, the first would be this complete is 32. From one end to another end, we have 32 bits. This is on our data bus also. We can use we are using 32 bit packets or 64 bit packets, so everywhere it can be used. The first is my version, then I have this IHL flag, then we have the type of service that would be followed by the total length bits. Then we would be having another layer. The first would be identification. The length of this version, IHL, and the type would be same as the identity ID. And here in the length, we would be having some flags, and then we would be having some fragment offset. Then we have something called time to live. That would be that would be TTL, time to live. That would be followed by the protocol used. That would be followed by the checksums. The next layer would contain the source, address, source address would be followed by destination. The destination would be followed by few options, and that would be followed by my data. So let us I hope those who have been into communication and ICT, they would be having an idea about these packets. So, like we have different fields. We would talk about the fields, uh, but let us find so. Okay. Mhm. Now, these versions would be the 3 bits, means 0 to 3 would be my versions. Okay. Or let me add it here. The 0 to 3 would be this. The next would be 4 to 7, 4 to 7. That would be followed by 8 to 15, 8 to 15. That would be followed by only this flag has some value. So that is 16 to 18 and later from 19 to 31. So the complete is the 32 bits. Now this identification bit would be my complete 16 bits. The length would be complete 16 bits. Now the source address would be 0 to 31 means 32 bits. Destination will also be 32 bits. Options will also be 32 bits. And then finally the data or the payload will again be 32 bits. I hope most of you were able to get this. Not the complete, but at least uh, my packet. And this packet is my TCP packet. Yes. Now, anyone has any question? Since this is something you guys need to understand. Fine, in case no one has any question, let us discuss the different things that we are having. The first you can see here is my version V. This version would be normally 3-bit long. And what it tells me is the format of the header, the format. Like uh, what would be the protocols used or what kind of transmission we are going to make. The next is my IHL that stands for header length, internet header length. So It will tell me what is the length of the header or the payload. So for a 32-bit packet, it will be 32-bit words that would be sent over each packet. 32-bit words. The next is my type of service. Here it was type. So that would help me with the quality of the packets that would be defined. That would be followed by length. That would help me understand the total length of the datagram or the data packet, means uh, how many octets of data would be sent. Like here I have showed, like this length might tell you that it is only one, but this data packet might be a bit longer as well. So this length would tell you the total number of octets that I would be sending in this data packet or the datagram. Then I have a identification bit or the ID bit. So this will tell you the title or the number. Like suppose, yeah, it can be comparable to somewhat like page number. Similarly, the packet number. So where do I put this packet? Suppose I am sending 10 packets. So it will tell you it is the fourth packet, fifth packet, ninth packet, or whatever it is. So that would be the identification bit. There, then we would be having a few flags that would be offset, and this will give you control for the packets. Then we would be having offsets. This offset might tell you that this packet is a part of which data block. Now suppose I have a 1 GB of data block, yet I have 1 GB to send to you. Now 1 GB won't be directly converted to a data packet. It would be converted into block. That block might be converted into datagram, and that datagram might be converted to data packets. Now this offset will tell you this packet is a part of which block or which datagram. Then we have something called the TTL or the time to live. This is like this packet would remain alive for a particular amount of time. Now what happens is we have understood that whenever we are sending or we have sent data, it might go to a lot of computers or a lot of devices. Now in case every data packet remains alive for infinity, that will choke the communication channels. So what happens is every data packet will be available for say a few seconds or a few milliseconds or a few minutes. After that, it will die of its own, so that the communication channels are not blocked. The devices, like I have 10 devices on my network, and all the 9 devices would receive the data packets, and that data packet might be, suppose someone is not having a very good thinking, So he might use that data packet. To avoid all these situations, we are adding this time to live so that we every data packet gets killed on its own so that the network doesn't choke. The data is not used by anyone, yeah, any malicious one. So that is my time to live. That would be followed by the protocol I would be using. Uh, the type of protocol, sorry, eh, the type of protocol I would be using, that might be IP or UDP or whatever protocol I am using, which we would be learning a little later. Then we are using something called the checksum. That is my header checksum. So these header checksum uh, mm, is used to check the authenticity and how good this uh, packet is. Uh, how do I make you understand about the checksum? So checksum will tell you how good mm, is the mm, reception good enough. So what happens is uh, mm, now yeah, it is already defined, for each protocol we have a checksum function which is already decided. Fine. So what will happen is these checksum yeah, would contain 8 bits, right? For a particular data block, we have a checksum function defined, and that checksum function might use addition, might use subtraction, might use multiplication or division or any of the mathematical or logical functions. Now, once I have this checksum function, I will put all the checksum inputs here, all the things that is there in the checksum block, and that will help me know the output. And since I already have my function, I also know what should be the output. Suppose the output should be 101. And now what happens is running through this function, what I get, the checksum comes to 100. This will mean that my data packet has been corrupted. Now, depending upon the difference between the checksums, I can make out what is the kind of uh, difference is there. Now, in case the difference is very less, it will mean that there was some problem with the transmission and the reception and the transmission channel. But in case it is very big, now suppose I should get 101 and it gets to somewhat like something which is out of scope. Now somewhat like 11111. This means that something is there that might be malicious, that might be a threat. This much difference cannot come on its own because of the problem with the transmission channel or something. So these checksums are used to verify the authenticity of the data packets, the amount of should I call it um, the amount of corruption that might have crept in. So that is what we have for our checksums. The next would be our source address. This is something I believe I have been telling again and again. Uh, so this, since I have been telling again and again, this means that this is one of the most important part of our data packets. So source address. Now based upon the source, you understand the kind of packet you are receiving. Now, suppose I am receiving something from five people. One is my father, one is my mother, one is my wife, one is my friend, and one is my student. So I know that in case it is my father, he would be giving me something which has value of usage, right? In case it is my mother, it means it has some emotional bonding. So emotional thing. So source address will help you understand where it is coming from and what this packet can be all about. Then we have the destination address. This destination address will help the receiver know whether this packet was meant for you or for someone else. In case it is not for me, I will not proceed and read the data. And this packet would be killed within this time to live. Right? In case this source address is, I know where it is coming from. Was it intended, like, was I supposed to receive a packet from this device or not? Destination will tell me whether this packet was sent only to me. In case it was sent to me, I will process. In case it was not sent to me, I will leave it. And this packet will automatically die once this time to live uh, amount has been passed. Then we have the option. This, as the name suggests, this is an optional field and it might have a variable length. It might contain the root. It might contain any other field the sender might feel like. Then we have the data or the payload. Data which can be said to be my payload. Now, guys, anyone who is having any kind of question, please put in. I understand that this is something very new to most of us, even for, yeah, like for almost everyone. So it is natural that there would be a few questions that would come to your mind. So in case anyone is having any question or any of these bits that is not understandable or anywhere you feel, just let me know. I will take that question again. Fine. Then we have the data or the payload section that would contain the actual data or the information that was meant to be sent. Right. So that is that would be my data and the payload, and this would be followed by something like a trailer. This trailer would help you understand that this packet has closed. Now, many of the data packets might not contain a trailer, and like the IP packets, they won't contain a trailer. They would contain the data or the payload at the end, and that would close the complete packet. But we can have Ethernet frames, we can have a few datagrams that might contain trailers. So the trailer means the end. In case I am using a IP packet or a TCP packet, that would close with the data or the payload. So this is how my uh, data packet is. Now, I believe many of you would be having a few questions. Just let me know. These packets would be coming up again and again. This is my IPv4 packet. Other packets would be having different length of the different fields, but they would be having almost uh, a similar structure, but the field size might be a little different for many of them. Now that was almost, I believe, 45 minutes I have been talking continuously. So I believe till now a lot of questions might have crept in. Please, in case it is needed, we might talk about the packets again. The UDP would we would be talking also. That is also needed. Fine then, no one has anything to say. Let us talk about something called protocols. We would be coming to these data packets again. Huh? आजा, फंसा। हाँ? अंदर में। Guys, anyone having any question, please. Let me know. I will come to that again. Now let us talk about protocols. What do you understand by a protocol? What according to you is a protocol? Are you guys still there?
Sir,
Hmm. Yes, tell me.
sir, we are here.
Okay. So, but you no one is speaking anything. So you guys be like here, kid, make me stop. Even if I am talking, make me stop in case you have any problems or anything to say. Now, what I asked was protocols. What do you understand by protocols? Yes. What do you understand by protocols? No need to Google it out. Just set of rules. Yeah, very correct. So protocols are nothing
Sir,
but
I
a
think rules are regulations.
yeah, very correct. Protocols are the standard rules, the set of rules that define a communication. Now, in case we talk about a normal example, it can be somewhat like protocols. In case we talk about how we define protocols. Now, uh, suppose we some minister comes to your college, so everything is defined. He would reach your college at 9:45, and he would be received by the principal and the secretary. So that would be how he comes. At 9:50, he would be moved to the guest house, and in the guest house, he would be having a small talk with the uh, principal, the HODs. At 10, he would be having breakfast. And the breakfast would be for 10 minutes, and these are the things that would be provided. So, this is a protocol, how everything is defined, or how uh, everything goes on. That is my protocols. Similarly, in case we talk about computer networks, so protocols are the set of rules. Protocols are the set of rules that define the transmission of data in our network. This is something which we need to understand. The devices can be different, but normally we define protocols can be defined for means like even out of the networks. So that is define the transmission of data in between a network, in a network, or might be out of the network. So both would be correct. So I believe you guys know this, and there is nothing new in here, but we need to understand the definition. I believe everyone understood. Now, let us have an example. This is my sender, and this is my receiver. Now the sender sends in something like a request to connect. Now this receiver will send you some kind of response. Now that response would be, okay, I have got your got your that could be instead of calling it a response, let us call it as acknowledgement. It is acknowledged that I have received your request and I am working on it. And that channel has been given to you. You might transmit your data on it. So that would be uh, fine. So this will give you the address, or this will help you with the address. And now once you send it the address, it will send you back the file you have requested. So what you do is you send a request. Okay, I want to open a communication on your channel. This will say, okay, your communication has been initiated. What do you want from you? You give it the name. You give it the name, and once you get the name, it will give you the file. So this is normally how a protocol works. Now this is normally a protocol. Now I hope you guys understood this. So every kind of protocol would be having its own set of rules. Now here, this example is normally for my transmission control protocol, for my TCP protocol. You give a request, it gives you a reply or an acknowledgement that the communication channel has been settled in. You ask it for a file. That file can be the name of the website, and this will send you the file that you have requested. I hope you guys were able to understand this. I think this is getting okay. Now we need to know that we can have different types of protocols. The first is my transmission control protocol, the TCP. That stands for transmission control protocol. Now, guys, please say something. What do you think this transmission control protocol is? Now, this was an example for my transmission control protocol. This is how it works. Connection request is sent. Once the communication request is sent, it would create a connection, and then it will receive the file name and it will send the file. So this is connection oriented. This is basically connection oriented. That is the first and the foremost thing about this TCP protocol. This connection oriented means that a channel or a channel or created connection is created uh, before any transmission takes place. Connection between channel yeah, between applications is created before any data is sent or received. Now, in case I talk about the various examples, so data is streaming, like streaming, video streaming, buffering. So that would be an example of the TCP. The other can be my mails. They are also being using this TCP. Now communication channel is created first, and then you send in. Uh, the best example can be the file transfer. So that is my transmission control protocol. The next would be my UDP. Mm, I believe you guys understand UDP is for user datagram protocol. So the next would be my UDP, user datagram protocol. Now, UDP was now any ideas about UDP? I hope many of you have used it. Now, in case we talk, I think it is getting okay. Fine. So let me draw. So we had this TCP protocol. Now, similarly, someone is sending something. Time sensitive applications. Fine. Fine. Now I have the sender, I have the receiver. Now, this was something, I this was something in the opposite direction. Okay. Now what happens is the receiver sends a request and means the case is receiver, it is me who is requesting you. Here also I made a little mistake. So the receiver is me who has to receive the data file. So I will ask you for a request. Yeah, like I would ask, give you a request. Yeah, need this. So once I give you a request, you will send. Now, since I have not created a communication channel that is reliable, and this would be dedicated, what you do is you say keep on sending data again and again till You feel that it is all I have already received it. Right. That is my UDP protocol. Did you guys understand this? So, means like here we created a channel. Okay, data would be sent on this channel only. Here it is not happening like that. It is not creating a dedicated channel. It is sending data. Like means like might be you guys would be thinking like there is no like I am not talking about a physical channel. Since there is a cable or there is a medium, but I am talking about a logical channel that is created between the sender and the receiver. In the case of an UDP, no logical channel is being created. The data is being sent over the network, and it can means in cases it might not be unicast, it might be multicast, where the sender is sending data and it is being received by multiple people or multiple devices. It might be broadcasted so that everyone on the network receives the data packets, but based upon the source and the destination address, it will know that this packet has of no use to me. It will drop. I'm not sure that was clear for everyone. Guys, please let me know in case you were able to gain even a little of this, or it has been already very long and you guys are feeling tired. Yep, someone has said, yes, Archana, tell me. I don't know when you raised your hand. Yes, Archana, sorry, I did not notice. Time sensitive. Okay, good. Archana, I am listening to you. You might say whatever it is. Oops, Archana.
Sir, can you repeat once more?
About this UDP or this TCP also?
UDP.
UDP. Now, what happens in this UDP communication is the receiver who has to receive the data packets, he sends a request to the sender. Okay, this is a file that I need. Now, what happens is the sender does not create a logical communication channel. Okay, like suppose this is my sender. Sorry, this is my sender. Yes. This suppose this is we have several devices here. Suppose this is my receiver and this is my sender. This receiver sends a request to this sender. Hey, I need this file. In case it is a TCP channel, what it will do is it will like we already have this bus. It will create a channel. Ki, acha, this is the fastest and the easiest path to this this device. So let me create this channel. Now, once I have this channel, I will send everything on this channel only till my complete communication is completed. So that is my TCP protocol. But in case of UDP, this logical channel is not created. This receiver sends a request, and this sender will set this file. No logical channel is created. No optimal path is created. So the file would be received by this, and by everyone on this channel. And based upon the source and the destination address, this computer will know that this file is not for me. He will rebuff it. This will know this file was not for me. It will be rebuffed. This will know that this file was for me. It will keep it. For these, the TTL, that was the time to live, will define how long it will remain on this computer or on this channel. That every packet has a TTL, the time to live. The packet will be remain alive only for that amount of time that is in the TTL. Once the TTL is passed, the file is degenerated, or it is it is closed, like it is no more available. So that is my UDP. It can be used for unicasting. It is used for broadcasting. It cannot be created. It can be used for multi and broadcasting. It can, like, it doesn't support unicasting since we are not creating a logical channel. But TCP, we are creating a logical channel. That is why one-to-one communication is very easy on TCP. But for UDP, that would be a bit costlier. That is why we are using UDP for multicasting and broadcasting purposes. Any questions? Was it clear now? The best example where we are using this UDP, it would be our streaming games. That would be my UDP protocol. That is where it is using. Mm, like again, we are streaming. What do you call? Streaming a movie. It can be. It is not unicasting. Normally, it is not. Uh, we have that concept that came up recently, that you can ask your service for, yeah, like service provider, I need to watch this movie, and this movie would be available only for you. I don't know. Like I am not mm, getting that word. What was it called? Movie on demand. Sorry, yes. So movie on demand. But I am talking about streaming, where everyone has access. So that is my UDP. Then we can have online games where everyone can join in. It is not for a particular person. But when we are talking about mails, it is for a particular communication channel only. It has to have a logical address. So that is what we have for TCP. Then we have something called voice over yeah, like VoIP, voice over internet protocol. That is also using UDP protocols. So this is UDP and TCP. Now I'm not very sure if you guys were able to understand. So what I would suggest is uh, get back to this document and try to read TCP and UDP, try to Google it out a little. And then once we connect again in the afternoon, we would be taking this topic again. TCP UDP protocol needs to be understood very well. So we would be trying to understand it